Okay, in this video we're going to look at stationary points, exam standard question. We've got here a function f of x equals x cubed plus 4x squared minus 3x minus 7. And we've got to sketch the graph of f dash x and state the values where the original function f of x is increasing and where it's decreasing. Okay, so before we get to that, we're going to look at what scenarios will f of x be increasing or decreasing. We know that we've got two types of gradients. We've got our positive gradient and our negative gradient. So a function's increasing when it's got a positive gradient and decreasing when it's got a negative gradient. Okay, so increasing, decreasing, positive gradient for increasing, negative gradient for decreasing. Okay, so how do we know what our gradient is? Well, our gradient, we can get that from looking at the derivative. And by sketching the graph of the derivative, it gives us a lot of information about where the function is increasing or decreasing. So let's go ahead and do that. Let's sketch the graph of the derivative. The derivative is 3x squared plus 8x take 3. So we need to graph the derivative here on this set of axes that I've set up. Okay, so to graph this, to find the x-intercepts, we're going to factorise it. So we get 3, if we factorise this, we get 3x minus 1, x plus 3. Okay, so that's factorising the derivative there. So to find the x-intercepts, we make that equal to 0. And that gives us x-intercepts of a third and neg 3. So we're going to get x-intercepts here, neg a third, neg 3 and 1 on 3, which we can put there. The y-intercept of the graph will be negative 3. So we can mark that in here as negative 3. And look, really no other part of this graph is really all that relevant except for those key points. So this is a quadratic graph because its highest power there is x squared, so 3x squared. Its dominant term is positive, so when we graph it, it's going to look something like this. There we go. Okay. So now we look at the original question here. State the values where f of x is increasing, where it's decreasing. It's going to be increasing when it's got a positive gradient. Now let me show you here where its gradient is positive. Its gradient is positive there. Okay, that is x is greater than a third. It's also positive here where x is less than negative 3. Okay, so that way and that way we've got positive gradients. Where is the gradient negative? The gradient is negative in between negative 3 and 1/3. Okay, so summing that up then, we've got positive gradients, so it's increasing, so answer to B, B1, it is increasing where x is greater than a third and x is less than neg 3. That's where we've got positive gradients, and it's decreasing, we've got negative gradients in between negative 3 and 1/3. Now you notice I haven't included negative 3 and a third in either of those answers because at negative 3 and a third, okay, they are turning points of the original function. Okay, x cubed plus 4x squared minus 3x minus 7. Because that at those points the gradient, remember we're graphing the gradient here, I should mark that in. This is the graph of the gradient. At those 2 points the gradient is 0, where the gradient is 0 we've got stationary points. Okay, underneath here, in this area here, between negative 3 and a third, we've got negative gradients, therefore the function is decreasing. Over here and over here, that is less than neg 3 and greater than a third, we've got positive gradients, therefore the function is increasing. So to summarise then, the function's increasing where the derivative is greater than 0, that is positive. The function is decreasing where the derivative is less than 0 or negative number. Okay, and we're at a stationary point when the derivative equals 0. So there's our two answers. Okay, we've got a increasing function there and the decreasing function there. Next one is an exam favourite. These have been in quite a few exams in the last 10 years or so. If y equals f of x has the following properties, then sketch its graph. Okay, so its derivative equals 0 when x is neg 2 and x is neg 3. So we know they're going to be stationary points. Next thing we're given here is that the gradient is less than 0. Okay, that is, it's negative between negative 2 and 3. Third thing that we're given here is that the gradient is greater than 0 for all other values of x. So that would mean less than neg 2 or greater than 3. Now it's worth pointing out here we haven't got enough information to get x or y intercepts here, so we can only give an example of an answer. What we do know is that we've got turning points at 3 and neg 2, why? Because at those 2 points the gradient is equal to 0, and we know that we've got negative gradients between those 2 points, positive gradients at other times. So what we're going to end up with here is 2 turning points, okay, there and there. Now why have I put them there? Because we know that except for between neg 2 and 3, the gradients are going to be positive. So our slope is going to come down here first of all. Then the slope is going to turn to a negative gradient. And then it's going to turn to a positive gradient over here. That's a possible answer. Now let's see if it all checks out. That's what we have to do here. If we look at our gradients between neg 2 and 3, okay, we'll notice that we've got negative gradient there. Okay, as far as gradients everywhere else, positive and positive. Okay, so our gradients match up there. All right, so that would fit that background information. These questions can look quite complex and difficult, but that's really all there is to it. We have to put the information together. We've got the 2 turning points there. We've got negative gradients between them, positive gradients everywhere else. Okay, so there's an example of some more advanced questions, some exam standard questions from the topic of stationary points.